What is cognitive psychology? The topic of today's video covers pages 3 to 8 and 17 to 20 in your textbook. Today we'll discuss the nature of cognitive psychology and its methods for understanding the human mind. The term cognition derives from the Latin word conoscere, meaning to get to know. And if you break that word down further, co means together and nocere means to know. This allows us to think about cognition in a couple of ways. I'll mention a second interpretation toward the end of this video. But one interpretation that I want to begin with is that it's the bringing together of different kinds of information in order to form knowledge. So when you acquire knowledge of an object, say a car for example, your mind unites its various features, including its typical shape, function, and its manner of moving. These individual bits of information come together to form knowledge, or what we will be calling in this course a mental representation. The term mental representation is a central idea in cognitive psychology, and it'll come up again and again in this course. It's also one of the ideas that confuses students the most, so it's important that we spend some time on it now, and over the semester your understanding will grow and deepen. A mental representation involves the ways we symbolize or represent external reality in our minds. Think of a symbol such as the peace sign. The peace sign itself has no intrinsic meaning. Someone who doesn't know what the peace sign means cannot figure out simply by studying it, studying the image, what it's about. Rather, this is an arbitrary combination of lines that abstractly represents a complex idea such as peace. Next, let's think of a computer. On your computer are perhaps stored music files, photos, and numerous programs such as Microsoft Office. However, you can't find images or music in the physical hardware itself. This information is stored and represented using an abstract system of binary code. And when you activate a certain program, your computer translates this binary code into the photograph you see on your computer screen. In the film The Matrix, all of reality is represented by such a code. Similarly, mental representations are a kind of code stored in the mind. Your mind translates this code into the conscious experiences that make up our worlds. But unlike a computer or a peace sign, our mental representations are physically stored in our minds as a pattern of firing brain cells. When a unique pattern of brain cells fire, it activates a specific mental representation, which can give rise to what we call conscious experience. Mental representations will be essential for understanding a lot of different applied issues related to cognitive psychology. So for example, we have mental representations not only of cars and other everyday objects, but we also have mental representations of what it means to be in a relationship, a mental representation of what a certain kind of group of people are like. We have mental representations of ourselves. And these mental representations help us to think about situations, mental health issues such as depression, for example. What kind of mental representation does an individual with depression have? We might call this a self-concept, for example, instead of a mental representation, but we're referring to similar things. A lot of cognitive therapists will refer to schemas, right? These sort of mental blueprints that we filter the world through, and in the case of depression or other mental health conditions, can sometimes lead us to distort our perceptions and make it more likely that we're going to get depressed. And then when it comes to interacting with people of different races or ethnicities, and we have a certain mental blueprint, schema, a mental representation of those groups, and this can operate on an unconscious level and often does, but it influences our behaviors, our emotions, and a lot of other aspects of our everyday activities that are outside of conscious awareness. So mental representations are really important to a lot in this course. The topic of mental representations also continues to be a debated concept among scientists and philosophers. And there's a lot of sort of unanswered questions. So for example, are some mental representations innate, or are they all developed from experience? How do we acquire new representations? And how do our existing representations change over time? That's a pretty important question for therapy. How well do our representations match reality versus distort it? Now, moving into a little bit of the neuroscience, how do patterns of firing brain cells get converted into conscious experience? That's a very profound philosophical question that we'll explore toward the end of this course. And then finally, if mental representations are invisible, how could a scientist study them? And it's that last question that will be the next topic in this video. But before diving into the scientific study of cognition, I should mention that there remain debates about the nature of mental representations. For example, the notion of a mental representation supports a kind of binary between the internal world of our minds and the external world of reality. This gives rise to all sorts of difficulties, philosophical difficulties in particular, as to whether we could ever truly know reality in itself, or whether that question even makes any sense. Second, the idea of mental representations suggests that the mind is sort of like a theater that puts on a performance inside our heads. But who is watching this theater? Is it the self? And if it is the self, isn't the self just another mental representation? And if so, who's watching the self? Who's watching the show going on in our minds? This problem leads to what's called an infinite regress, in which watchers are watching watchers who are watching. We'll move on now to the second and final topic of this video, answering the question, how is cognition studied scientifically? When I say scientifically, I mean a method that carefully measures the activity of the mind in order to uncover distinct abilities, their relationship to brain areas and functions, and how we can predict certain outcomes such as academic achievement, job performance, but also understanding neurological disorders, mental health, and various social behaviors. The challenge of scientifically studying mental activity is that we can't directly measure it. This difficulty of studying mental behavior was one of the major reasons for the rise of behaviorism in the early 20th century. Our next video will talk about some of this, but to say it briefly, behaviorism rejects the mind as an object of scientific study. Rather, the behaviorist argues that scientists should focus on what can be directly measured. A, the environmental stimuli as the cause, and B, the effect, the behavior as the effect. Through careful measurement of these two sources of information, it was thought that we could establish causal relationships that explain human activity without having to refer to that black box called the human mind. A problem with this approach is that many anomalies begin to show up. The same type and amount of environmental stimuli give rise to very different behaviors. There are at least two possibilities that can explain this finding. One, perhaps these discrepancies are due to insufficient knowledge of all the environmental influences on an individual, and especially the unique history of behavioral conditioning leading up to the moment that the particular behavior is being studied. So in this sense, predicting behavior is like being a weather forecaster. We may be able to predict general trends, but there are simply too many variables to perfectly predict how any single individual will behave in response to certain environmental stimuli. The problem with this explanation is that you can never really disprove the theory of behaviorism, and that's a fundamentally unscientific attitude. In other words, the theory lacks falsifiability. Another problem with this explanation is that some complex behaviors seem to be logically unexplainable by experience alone. The prime example here is language. Despite behaviorists claiming that language is learned through a history of rewards and punishments, the amount of learning in the first few years of life without any real structured direct training seems highly improbable from experience alone. Rather, perhaps there are some innate mental capacities that speed up the language learning process. So while the environment may be necessary for language, it's not sufficient. You need some preloaded capacities for acquiring language in order to learn it at the rate that children do. By including cognition as an intermediary step between the environment and behavior, or between stimulus and response, you can start to explain behavior a whole lot more effectively. Yet this leaves the problem of measurement of the mind still open. Because the mind is not directly measurable by our instruments, we have to still indirectly measure it based on behavior and neurophysiology. From these measurements, cognitive and neuroscientists infer the mental processes that must be in place to explain our experience and behavior. The behavioral measurement of cognitive abilities includes A, accuracy, and B, speed. For an example of accuracy measurement, let's say we expose individuals to a set of 50 words and 50 images. I'm just making up this study, but it's based on some truth in cognitive science. So you expose individuals to those 50 words, 50 images, and a week later, they're exposed to the same words and images and asked to identify which ones they saw previously. And mixed in are some images and words that weren't presented a week ago. Now let's say that these individuals had a 90% accuracy for images, but only a 30% accuracy for words. And we determine using statistical analyses that this is a significant difference. What does this tell us? Well, first and more obviously, it tells us that we're better at learning and remembering images than words. But more importantly, it suggests that perhaps memory is not one process, but in fact, there are at least two kinds of memory systems, one for verbal information and one for perhaps visual information, or one for language and one for images. This gives rise to a whole series of research questions that we could ask. So for example, do we process verbal and visual memories in different parts of the brain? What is it about images that make them easier to remember? Can we use this information to somehow improve our verbal memory by creating more mental images? We could address the same question in another way. Let's say not only were individuals more accurate in recognizing images, but they were also faster in responding to those images they recognized compared to words they recognized. So this finding suggests something slightly different. Not only may it be easier to remember images compared to words, but it may also be easier to retrieve those images that are stored in memory compared to those words stored in memory. In general, when it takes more time to respond, this suggests that it's a more cognitively demanding task. This may be because such a task requires more brain areas and so therefore evokes a longer response time. A clinical example of this is found with reading disorders. Some individuals have difficulty recognizing letters and words, and so they're less accurate at this task. One explanation for this, though it's not the only, is that individuals with accuracy difficulties had trouble converting the visual letters into their equivalent sounds, what is called orthographic processing. However, other individuals may have perfect accuracy, recognizing letters and words no problem, but are much slower in recognizing them. Those with high accuracy but slow response times may have a difficulty with a different kind of cognitive activity and may involve a different brain region. So here it may be about information processing speed, just the general ability of quickly converting and responding into information. Throughout this course, you'll encounter research that often employs measurements of accuracy and response time. You'll also encounter these forms of measurement in your ZAPS lab assignments throughout the semester. Another way of measuring cognition draws upon the methods of neuroscience, especially clinical neuropsychology and neuroimaging. Since Chapter 2 covers the neural basis for cognition, we'll discuss these methods next week. In closing, I want to return to our beginning discussion on the etymology of the word cognition. I mentioned that one possible interpretation of its Latin root, conoscere, is that it's the bringing together of various forms of information to form knowledge. However, I'd like to offer a second interpretation, that conoscere can also mean knowing together, in the sense that knowledge is not something that is simply in our heads, but rather is a kind of shared experience among others. In other words, we can't know anything in a vacuum, but rather we always acquire knowledge through our relationships with other people. That we teach and we share knowledge, and without this, there could be no knowledge. So as such, cognitive psychology is not simply the scientific study of mental contents, what's in my individual brain, but more importantly, it's a study of how we arrive at a knowledge and how we arrive at it together.